All right, here's problem number 16. Very similar to problem number 15. But this is for Mars. They give us the mass of Mars. They give us the radius in kilometers. It says calculate the surface gravity in meters per second squared, round to one place past the decimal. All right, so the one thing is that we have to change the radius immediately. The radius of Mars, we have to change it into meters. All right, so it's 3,389.5 kilometers. Right, and we know that in 1 kilometer, you can just do this directly. You're going to multiply by 10 to the third, right? 10 to the third meters in 1 kilometer. All right, so that's it's just the same number, 3,389.5 times 10 to the third, E3. All right, so that's going to be in meters. All right, so and then the acceleration due to gravity, a sub g, is equal to, of course, big G times the mass of the planet or whatever you're trying to escape from. That's got to be in kilograms, which it already is, divided by the radius in meters, but you have to square it. All right, so let's put the numbers in and solve this problem. All right, so just like the last problem, 6.67, the universal gravitational constant times 10, that's a 7, times 10 to the minus 11th times the mass of Mars is 6.4, that's a decimal, times 10. It's just easier to write the E to the 23rd, right? So that's because it's Mars, it's much smaller. And then we divide by the radius, right? So 3,389.5 times 10 to the third, but you got to square that. All right, so that's the way that this formula works. And let's put the numbers in, and we're going to round to one place past the decimal. So hopefully we'll get 3.7. All right, let's take a look at that. All right, so let's clear this. All right, so it is 6.67 times 10 to the minus 11th times 6.4 times 10 to the 23rd divided by, all right, so we're dividing by the radius of Mars in meters, which is 3,389,500, or you put 0.5 times 10 to the third. It means the same thing. But remember, we've got to square that. All right, so squared, and then hit equals. There it is. All right. So rounding it to one place past the decimal, it would be 3.7. Right. You don't round up because the next digit is a 1, and so that's 5, or that's below 5. So the answer turns out to be 3.7 meters per second squared. Right? Significantly smaller than the value on Earth. Right? The acceleration due to gravity on Earth is a very famous number, 9.8 meters per second squared, which was measured, by the way, by none other than Galileo 400 years ago. And he even measured it without using a stopwatch, because they didn't even have stopwatches back then. They could not record time down to the second 400 years ago. All right, so it's pretty remarkable how he was able to. He actually used his pulse as a timing mechanism. All right, so anyhow, that is the last of the problems. Study the problems. Make sure you know how to do these, and you'll be ready for test 2.